The James Webb Space Telescope has uncovered a series of mysterious structures that challenge our long-held beliefs about how the cosmos evolved. In fact, some of these findings are so fundamentally at odds with existing theories that, by all accounts, they shouldn't even exist. As a result, the standard model of cosmology is facing growing scrutiny, with an increasing number of experts questioning whether the universe truly began with the widely accepted Big Bang. So, what exactly did Webb discover in the far reaches of space? And if the universe didn't originate from the Big Bang, how did it begin? Stick with us until the end as we dive deep into these fascinating questions. To begin, let's address a broader and very intriguing question. What lies at the edge of the universe, and what does it look like? The most honest answer is, we simply don't know. And that's not surprising, considering we aren't even sure whether a cosmic edge exists in the first place. Despite all the space missions, probes, and advanced telescopes at our disposal, the full extent and true shape of the universe remain one of the biggest mysteries. The Big Bang theory generally proposes that the universe is spherical, but that's just one of many possible models. Scientists have also considered other shapes, such as a torus, donut-shaped, or even a trumpet-like structure. But how, and this is a perfectly valid question, can something infinite be transformed into a higher-level form? Although the terms universe and infinity are often used together, the truth is, we don't actually know whether the universe is truly infinite. What's important to understand is the distinction between infinite and unlimited. Even if the universe has a finite volume, it could still be boundless. At first glance, that may sound contradictory. But it doesn't have to be. To explain this idea, scientists often use the analogy of an ant walking on the surface of a balloon. The ant can keep moving in any direction and never encounter an edge. It would appear as if it's traversing an infinite space, even though the balloon itself is clearly finite. Of course, this is just a simplified illustration. Unlike a balloon, the universe isn't believed to exist within a higher dimensional space, at least not according to classical cosmology. Now, let's consider the idea of the universe having an edge. Despite many uncertainties, it's reasonable to think that our universe does have a boundary, or at least, a visible one. This is where the cosmological principle comes in. It states that the universe looks the same in every direction, no matter where the observer is located. Around Earth, there's a spherical region of space that limits how far we can see. Since the Big Bang happened roughly 13.8 billion years ago, it might seem logical that our cosmic horizon lies 13.8 billion light-years away. But that's not the case. The universe is not a static structure, it's been expanding since the beginning of time. And it's not expanding into something else, rather, space itself is stretching. Because of this expansion, the light from distant objects has been traveling through a growing universe, meaning the distance to the cosmic horizon is actually about 46.6 billion light-years. Interestingly, the galaxies and cosmic structures we now see at that edge were just 40 million light-years away when they formed. But since they've passed beyond the event horizon, we can no longer observe what's happening there now. What we see is a snapshot of the distant past. And what lies beyond the observable universe? That remains a deep mystery. Some scientists believe that the unseen regions are much like the parts we can see. Others suggest that completely unknown, unimaginable structures could exist out there, far beyond the limits of our observation. The present, and future, of modern space exploration is written in the stars, and its name is Webb. Launched into the vastness of space on December 25, 2021, the James Webb Space Telescope is up to 100 times more sensitive to electromagnetic radiation than its predecessor, Hubble. It's so precise that it could detect the warmth of a bumblebee on the moon's surface, from Earth. But, of course, this $10 billion marvel wasn't built to track tiny insects. Its true mission is far more ambitious, to explore the first luminous structures and galaxies that formed after the Big Bang and the mysterious Dark Age that followed. And so far, Webb has not only met expectations, it has surpassed them in spectacular fashion. When the first images were released in July 2022, they stunned the world. The detail was unprecedented. Webb captured regions of space that had remained hidden from Hubble and similar observatories, even identifying the oldest galaxies ever seen. Some of these ancient galactic infants were already shining just 290 million years after the Big Bang. But these stunning revelations are only one side of Webb's story. On the other side are findings so unexpected, so seemingly impossible, that they've sparked what some are calling the greatest cosmological crisis of our time. It all began with something that appeared deceptively simple: 6 faint points of light. These unassuming objects would go on to earn a dramatic nickname, the universe breakers. Why such a name? To dig deeper into Webb's first near-infrared images, researchers from Swinburne University of Technology in Melbourne reanalyzed data captured near the Big Dipper. What they found was extraordinary: 6 reddish, glowing objects. Based on their redshift, they appeared to be more than 13 billion years old, meaning they existed just 500 to 700 million years after the universe was born. Further analysis confirmed that these points of light had the traits of very early galaxies. But here's the shocking part: they weren't small, primitive structures like scientists expected. They were huge, as massive and developed as our own Milky Way. This discovery defied logic. How could galaxies have grown so large, some containing over 10 billion, and one even more than 100 billion, solar masses, when the universe was still so young, and the matter required to form them shouldn't have existed yet? Faced with this staggering contradiction, astronomers were left questioning their models. Could such a massive error really exist in our understanding of the cosmos? Or was the James Webb Space Telescope revealing a universe far stranger, and far more advanced, than anyone ever imagined? However, repeated data analyses confirmed that these seemingly impossible objects were indeed real. Even if just one of the newly discovered galaxies turned out to be genuine, it would have shaken the foundations of modern cosmology. That's because explaining their existence would require the matter density in the early universe to be up to 5 times higher than previously believed. The only other explanation? These galaxies must have formed in a way we don't yet understand. Either scenario throws our existing theories about cosmic evolution into serious doubt. So how do scientists respond to a discovery that defies all logic? First, they add it to the growing list of impossible finds made by the James Webb Space Telescope. Those early shocking discoveries were only the beginning. Since then, Webb has continued to detect structures that, by current cosmological standards, simply shouldn't exist. Take, for instance, the most recent finding from late May, a galactic sibling to the Milky Way, but one already 10 times more massive than our galaxy is today. This has raised a critical question: does the Big Bang theory still hold up? Altogether, Webb's astonishing discoveries are casting doubt on the standard model of cosmology and pushing scientists to explore alternatives to the long-accepted Big Bang. And some of these alternative theories are as fascinating as they are bizarre. Could we be living inside a black hole? Is our universe just one small link in an infinite chain of universes? Or could it all be a vast simulation? Eventually, even the cosmos must reach an end, and one theory addressing that finale is known as the Big Crunch. It suggests that gravity will one day reverse the universe's expansion, causing it to collapse in on itself, a kind of reverse Big Bang. Taking this idea further, some theorists propose the Big Bounce. The universe collapses, then rebounds in a never-ending cycle of birth, death, and rebirth. In this view, each collapse sparks a new universe. One particularly bold idea comes from Nikodem Poplawski at the University of New Haven. He suggests we might already be inside a black hole. According to his theory, our universe began as a tiny, dense seed, trapped within a gravitational giant. When the compression reached its limit, this seed, weighing billions of solar masses, burst open and kick-started the cosmos as we know it. As intriguing as these alternative theories are, they still leave us with profound questions. What came before? Was there even a before? If not, how did something emerge from nothing? These mysteries push the boundaries of human understanding, and whether we'll ever find definitive answers remains, quite literally, written in the stars.